Good morning, everyone. Welcome and thank you for joining us for the AI-powered build, generative design, robotics, and automation in the future of construction. My name is Joe Broon. I'm the Managing Director of Building Digital and today's host of this online micro conference. Today's session explores one of the most important shifts our industry, every industry, has ever faced. How artificial intelligence is moving from theory into real-world application across the entire construction life cycle. From generative design tools that reshape how we conceive buildings to robotics and automated systems that are transforming how we physically construct them, AI is redefining what's possible. Across this session, you'll hear from leading innovators working at the cutting edge of design technology, robotic fabrication, and intelligent systems. They'll share practical insights, real-world applications, and forward-looking perspectives on how these technologies will shape the future of architecture and construction. I'd like to introduce our first keynote of today's online event, which is Cesar Fragachan Pinzani. Cesar is the founder and CEO of Aalter, a company focused on leveraging artificial intelligence to transform architectural design processes. With a background in architecture and computational design, Cesar is working to redefine how buildings are conceived using AI to augment creativity, automate complex decision-making, and unlock new efficiencies in early-stage design. His work explores how generative systems can support architects in delivering better performing and more sustainable buildings. Cesar, if you're there, you are free to take over the screen with your presentation, please.
Thank you for the invitation to be part of this micro conference. As Joe mentioned, I'm Cesar, founder of Aalter. I'll be presenting today a little bit of, we're a startup here in the UK and based in London. And I'll be sharing a little bit about our experience in coding design intelligence. So at Aalter, we sit in the intersection between automated design solutions, that's leveraging a lot of our generative design tools with enhanced, basically presented in enhanced experiences in the form of with game engines and user participation in the form of online configurators. So for us, the way that we study and explore that design option is very important. And the more data that we have, even if it's visual, and being that part of the process is important. So our mission is basically to deliver mass customized spaces that are more sustainable, inspiring through intelligent design technology. For that, it's important to also mention a little bit some of past experience. So some of our team members were from Sahadi, the computational design group. So we've at the time we created a lot of custom software to win competitions at scales very fast, but also to rationalize complex geometry and create immersive, unique experience in the form of configurators. So we leverage these tools to create across different scales, master planning tools with real-time analysis, rationalizing building typologies, also rationalizing complex systems and complex cladding and geometry, so we can make it from the most standard parts and minimize basically the budget, and creating also configurators. So this was one 6 years ago. It was quite innovative at the time, using modular systems and timber frames to deliver a unique experience for an island in Roatan. And also, I think it is important to mention some of the precedents about encoding architecture. So we see it over the shoulder of giants. It's not new about like the idea of encode architecture. So throughout history, architects have been trying to encode some of these rules that are based in ergonomics, room functions, and also space layout, relationship between spaces, relationships between spaces and exterior, that sets some rules, and also encoding and trying to serialize a building out of data basically, and these graph relationships. So this has kind of like set it up on as present to founding Aalter. So our technology is quite simple on its own. It's basically a system or a set of relationships similar to a what would be an IFC or a BIM model nowadays, but with encoded intelligence of relationship between the parts, right? Like so every room is aware to where it's connected, to which walls is connected, to which part, so to which window, which is door, and then these extrapolate across multiple scales, right? Like because then we can understand how the circulation has a relationship to each of these units, to understand escape distances, to understand the different typologies, and at the end of the day, these becomes knowledge graphs, which LLMs are really good at querying and manipulating. So some of the tools that we've done and we're exploring, we're setting out there, it's basically connecting to different APIs, Google APIs, reconstructing context, allowing users to make parametric layouts that they live as data in their databases and are easy to then interpolate across different massing and different complex shapes. So it's also giving the designers the possibility, with the tools that they use to create unique designs and basically explore the design option with parametric systems that go from the range of manipulating geometry, but also to deploy some of these um, components parametrically in an easy to use interface. So we deal with all the complexities of rationalizing and retopologizing some of these geometries, and then all of these leaves us data in a centralized web app, so we can explore every option with all the data that is exported automatically for the users. So this is also very important, communicating with configurators. So this kind of sets a little bit our, workflows or pipelines that we have been working with, and we kind of customize. So if you go a little bit more into different application, different tools for master planning, the master planning level, so giving the designers the ability to stitch urban fabrics with input lines or input curvatures, and then basically be able to query between different building typologies based on zoning rules, field conditions, to make gradients, make work with the parameters of building shapes and building sizes with real-time feedback out of the data that they can extract. So another important thing is, since everything is geolocated, it's also very important to analyze some of qualitatively some of these buildings. And again, since we have already the information of the context, we connect to open APIs to get solar analysis, view analysis, and wind analysis. And the way this came also around the way that we designed it, Saha, having like heat maps of where a building could get more exposure to the sun. So then the designer has more control, or okay, that part needs to have more shading, or if there's a specific view that sits as a layer on those heat maps. Um, so the designers again very easily as well, or like the ability to encode a kit of parts, and then give that option of the user to say, okay, this kit can go between this and this range. It will be composed out of these materials, and then the system being able to allocate some of these components based on the massings and based on the user understanding. So there's no manual work here, but it's just about acknowledging, like, okay, you give the rules to the system of how this part can be deployed, and the system does it with the control of the user. Now we've been also starting to play out with agentic workflows. So it's communicating with LLMs. Again, we are exposing basically some of these tools to the LLM, and the LLM can already understand how the building is composed and all the relationships. So if you can say, okay, increase the levels of these buildings or rationalize it in this way, or just create some fillets around the corners of some of these buildings and deploy a part of this material, so you can be co-designing with these AI agents, the same way that you prompted for ChatGPT. And this happens at a different scale. So one of the things that we're using it a lot with some of the project that we're developing is, giving setback information, right? Like giving, okay, I want to have 20% of my units should be commercial use, and then it should be allocated on the ground floor. So the LLM is really good to making these connectivities, and we expose the tools to the LLM in order to be this co-designer. Give us a unit mix of 1 bedroom, 2 bedrooms, and then or even querying, right? Like say, okay, can you give me a level by level clustering of the units? Then also allocate some automated layouts, and then every layout will have an information of okay, where the bedroom might be, where the living room might be, and then having also these AI systems that understand how to deploy some of these furniture blocks that the designer can then manipulate. So it won't give us necessarily the perfect layout immediately, but it might gets us 80% in a quick way and an automated way. Again, all these is centralizing this database. So very easily we can start seeing, like level by level, what's the efficiency of each building. So it's broken down by buildings, by levels, and understand all of the development metrics that the developer wants to understand early on. And so every design implication has that connectivity. So connecting also with generative AI models to extract visualization, and also connecting to these online configurators. So whenever we create these parametric parts, it sends it to the database, so we can query each version of a design, and like that visual part, the real-time aspect of how it embeds within the context. If there's photogrammetry information out of Google, we can see it in how it fits with that environment. Then, some of the use cases that we've worked on, this is what our long-lasting collaborators, Stelling Properties, an amazing company that goes end to end to develop from land acquisition all the way to student housing. So we've helped develop a system based on their set of rules and their again, like their building system, to encode that information and give them to the designer team a parametric system that can be able to optimize some of these unit mixes based on their constraints. So constraints are really important in these systems, right? Like it's all about what your system can put out. Doing clustering based on the hot roll steels and the connectivity between them, if there are setbacks, how many parts do we have connected already to their financial models and to their bill of materials. So we can export all of those automatically. We can create Revit models automatically, or for them, we'll also help to curate a set of kit of parts, so we can explore every massing option and all the configurations, which are exponential, right? Like if you have three massing, three kit of parts, it's nine possibilities to iterate. And this communicates also with a real-time experience for the students. So the idea is that we can also present this in a novel way for students that are overseas to book some of their properties. I've also done some demos for Berkeley property, and this is something that we're doing more and more nowadays. These digital twins with embedded configurators. So again, this is not about just the marketing side, of the sales side. It's just also empowering users in a unique way to explore their future home, to configure it, the same way that people would buy a car and is able to customize some parts. It won't change the chassis of the car the same way it will not change the MEPs, but it makes every property unique to the specifications of the user. And then, well, this is like basically the last demo, also a house configurator in Miami. And I think this links very well with Molly's work. I mean, also, like, interestingly, I'm also teaching at UCL with Molly's partner, Jill's. We have a research unit as well there. And then, this idea that we can have curated kit of or template of houses, customizable to each unit, but without changing that much, again, like, like the layout, but it's about presenting it in a different way. So the developer, or in this case, also, and then the designers can already extract data from the final user that are going to live here, and takes us further in that design process. And if we can connect these, to fabrication system, I think that Molly will do a great job now showcasing what they're doing. I think that would be very interesting to also continue the conversation in the following panel. So that's a little bit of where we are at Aalter. I think I missed basically one little, like one little slide, just to, so if you're interested to know more, this is who we are, our website, and we can stay in touch afterwards.
Excellent. Thank you, Cesar. That was a really interesting presentation. Thank you very much. And we'll take this opportunity to ask some questions. Have we got some questions for Cesar, please? Please feel free to to raise your hand or do the raised hand symbol. Don't be afraid, or put it in the chat if you
I've
prefer.
got a question.
Yeah, go ahead. Do you just want to introduce yourself before you ask your question?
Yeah, of course. It's Gillian Ashworth here. Nice to see you, Cesar, after all those emails. I work at Building Digital as well with Joe. Just a couple of questions, I think, just to expand on what you said. That was a great presentation, by the way. Absolutely great to see how digital twins and automation are actually working behind the scenes in architecture. I think it's something we don't see very often on this side, or especially myself in publishing. So it was just a quick question, really. Couple of things, really. I suppose it didn't really go back to right at the start, but what are the biggest sort of data challenges in trying to get all this sort of information together? What are you facing at the minute, and what's holding you back, I guess?
Yeah, I mean it's a good question. Basically, it's interestingly every firm, every person, every architect has their own workflows. If you evaluate, for example, the work of any architectural firm, even within their teams, they work differently. So every project is assembled with different team members, and each team member brings something different. So every workflow varies, and then it's kind of like trying to understand what are the main challenges on those workflows, trying to bring them in, apply them. It's that I think that's one of the biggest challenges, trying to create a new way of designing that separates a little bit from the status quo, from what people are comfortable designing with. I mean, interestingly, for example, a software like Revit has been in the industry for more than 20 years. And, some people still talk about like, oh yeah, we're using Revit as if it was, like the state of the art in these type of technologies. And, it's been the same software for over 20 years, but only today we're kind of like being able to adopt, like that mindset. So I think that's one of the biggest challenges, right? Like trying to 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 partner up and to collaborate with forward-thinking individuals and companies in order to really make a digital transformation shift on some of these workflows that I understand from profession, because I'm an architect myself, and it's not easy to embrace this type of um, new ways or that are not comfortable to to work with necessarily from the beginning.
Yeah, that answers my question. Thank you very much. Is there any
Nice.
more?
Thank you, Jill. We have got another question actually on the chat from Ivy Accorda from Towers and Hamlins. Ivy asks, who owns the models Aalter created, and is it intended to be used during construction?
So, I mean, we worked with open source models. What we're kind of like is just basically connecting different dots, and some tools we think are generic enough, and we are sort of empowering people the same way that like that we used it in when we were working at Saha or on other offices. But what we kind of like leverage the more is when working with customized solutions. For example, take the styling property building configurator. That's something that is proprietary from styling. Embedding all their building rules and relationships with some of our core technology. So the idea is to get more and more of these customized solutions that or workflows that we don't pretend that there's one way of solving everything. We think that every chain in the construction can have its degree of flexibility and customization. So that's where we also help people, customize their own set of solutions, which are not transferable.
I hope that answers your question, Ivy. Got another question in the chat from Alexi, who's a mechanical engineer at Cooper Homewood. Alexi asks, what sort of open source models are you using?
So, I mean, we integrate with all OpenAI, Anthropic's model, which are basically open APIs. We also have all the graph geometry processing algorithms. We're not creating from scratch, so we are leveraging on some of them to build some of these graph relationships halfish meshes, open NURBs. So it's kind of like setting all these, which are these low level algorithms or libraries, and we're just basically trying to stitch the dot um, in a way that we think it's meaningful for designers to have more control.
Good stuff. Thank you, Cesar. I hope that answers your question, Alexi. I've got a question, Cesar, about scalability. So, how do you handle scalability when the number of configurations grows from what you're currently using? And also, what are the next steps for expanding this system to other use cases?
So at the moment, a lot of the tools that we do have been developed based on projects that we help deliver, as basically computational designers, so we start embedding some of these tools, and then these are all parametric, right? Like the way that you do a curtain wall, standard curtain wall are applicable to multiple ranges of projects, right? Like lures, exactly the same, some layouts. So these become almost like generic ways of developing. Now, when we need to go to more customized workflows, that's where it's not that scalable, and that's where it becomes a customized solution to specific pipelines. So once we go to construction, or once we go to more details, that's where you cannot have these generic tools. The generic tools are great for early stage feasibility, concepts, which will get you, that very quickly to that 80%. But then that last 20% is like the really hard part. And then trying to integrate and communicate, and that's where it doesn't it becomes scalable if you have a systematic way to build. If you don't have that systematic way to build it, but if you have the first part, which you are just an architectural firm, we can get it very quickly because the system is flexible enough to allow creativity so that's where we operate in modules, basically. Okay, the early stage module, which is generic, scalable, very scalable. The other ones, which are customer specific, and the idea is that a lot of people, in the construction industry, the way they see from design to construction is very standardized, right? Like it's very systematic. And then sometimes they see every building, they're almost like reinventing the wheel every time and every time. And you say like, okay, like we would have these. We don't need to redo these that we've done many, many times, but we can create like those procedures and identify where are those bottlenecks in order to create that systematized and parametric for the next pipeline of projects. And then that's where also like it becomes scalable, but with that uniqueness or that configure for that customized problem.
Yeah, sounds very interesting. And it sounds like you're probably spending a lot of tokens, I'd imagine, with the large
Yeah,
language models.
exactly.
Burning through those tokens.
Exactly.
We have got another question from Kevin Fielding at Shepherd Robson. Do you factor in statutory requirements, e.g., housing standards, in your design configurations? If so, how are you capturing these requirements?
Again, it really, so we have two ways of working. So our generic tools, or that we allow you to create your own set of layouts, which are. So basically, we trust that the designer, the user, will embed those standards in the layout that it creates, or we can configure those layouts or those specifications into that tailored or customized solution, in order that we make sure that rooms keep specific standards, and then there's some flexibility to play, or some degree of freedom on certain nodes or certain parts of the house to accommodate specific sites. But that it really depends on that degree of or each of the challenges, right? Like if it's something more generic just to explore fast, it's very easy for anyone to configure it. If it's very, very when we work with, when we collaborate with clients and partners, like these, we also embed those rules from early on, and then that might be that the design is less flexible than others, right? Like you're not going to be able to make free forms, or it's less that the designer is less tailored for an architect, but in this case more for if you're a home builder, right? How to configure it exactly to your specifications and always meet your standards.
Okay. All right, thank you. I hope that answers your question, Kevin. We've got another question from Richard at Sotec, who are a rain screen cladding manufacturer. Can you perform this takeoff type approach from non-model info, such as elevation PDF from elevation, which is typically the format sent to manufacturers using the AI?
That's an interesting challenge. I mean, we haven't done it from a PDF, like a takeoff from a PDF. It would be an interesting challenge. I think if we can with the use of AI, I think it's a feasible problem, right? Like deserializing, basically encoding those pixels back in, but we will need the digital representation from that we will need to take from the PDF, and then potentially have the takeoff from a cladding, which is very specific, right? Like it's area based and it's dimension based. So I think it's a doable problem. We haven't really worked with that type of challenge, but yeah, interesting to look into it.
Sounds like you got some homework there, Cesar. And on that note, we will move on to our next keynote. So big thank you to Cesar for a great presentation. Before we wrap up completely, I'd like to briefly reflect on our 4 keynotes today and some of the key insights from today's session. Firstly, we heard from Cesar Fragachan Pinzani from Aalter. Cesar showed how AI is transforming early stage design through digital twins, configurators, and automation. His platform enables real-time exploration of building options while staying connected to cost, materials, and delivery constraints, which in turn helps to bridge the gap between design and reality. He also highlighted a key challenge: adapting to different workflows across practices and driving adoption. Aalter's approach combines open source AI with bespoke solutions, supporting everything from student housing to customized residential projects. Our second keynote was Molly Claypool from AUAR. Molly reframed housing as a manufacturing problem, presenting AUAR's robotic microfactories that bring production directly to the site. These portable systems deliver factory quality timber construction without the need for permanent facilities, powered by software that link design straight to a manufacturing. By combining robotics with physical AI, AUAR is improving speed, cost, and scalability, offering a practical new model for delivering housing at scale. We then moved on to Loris Di Natalia from Zurich Soft Robotics. Loris introduced Solskin, a responsive facade system using soft robotics to optimize energy, daylight, and comfort in real time. Rather than relying on complex rules, the system uses AI to learn from user behavior and adapt over time. Built with resilient pneumatic components, it offers a flexible and modular approach to intelligent building envelopes, while highlighting the broader challenge of balancing user needs, energy goals, and system integration. And then we just heard our final presentation today from senior lecturer at Loughborough University, Shirin Dora, who focused on AI and project controls, showing how it can transform how we manage construction data. His system, construction.ai, connects information across documents to detect risks early and predict their impact on time and costs. It shifts teams from searching through information to simply asking questions and receiving clear, actionable insights. Trin's case study presented strong accuracy, pointing to a real opportunity to improve decision making and productivity across projects. So, thank you for attending today's micro conference. I think taken all together, today's speakers have shown that AI is not just a future concept, it's already reshaping how we design, build, and manage the built environment. The challenge now is how quickly and effectively to adopt these tools to unlock their full potential. Thank you again to all our speakers and to everyone who joined us today. Please do keep going back to buildingdigital.com. Thank you again from me, and enjoy the rest of your day. Thank you very much.